All right, now that we have completed the first half of this course, which was on a review of algebra, solving equations, polynomials, multiplying, dividing, distributive property, all kinds of things, exponents. We are now going to leave that behind, and we're going to go to the second half of the course, which is on statistics, which will probably mean more for many of you, simply because most of you, I'm assuming, will be taking Introduction to Statistics for your Analytical Thought course here at Susquehanna. So hopefully this will be an enjoyable section of Math 99, and you can learn something maybe that you had never thought of before. Today we're going to be working with mean, median, and mode. Many of you will probably say, wonderful, we did that back in junior high, and it should not be a problem. Well, it should not be a problem, but I'm going to be doing a couple of things with it to give you some other interesting things to think about when it comes to mean, median, and mode, and especially the way that mean, median, and mode is done with statistical analysis that you see on TV, on the computer. If you read newspapers or magazines, you see mean and median bantered about all the time, and I'm not really certain that people that do that in the media really even understand what mean and median mean. Okay, so we're going to go through some examples here. We'll talk about mean, median, and mode. It says find the median and the mean of these two sets of data. Okay, now to do that, you can do the mean. The mean is the same as the average. All right, so the mean is the same as average, which is the same as you want to add up all the data and divide by how many there are. This simply means add up the x values, add up the data, and divide by n, the number of data. And then median is the middle one. Like the easy way to remember that, the median in a large highway is the grass strip that runs down, or the concrete barrier that runs down through the middle of the highway. Okay, so let's first find the mean for both sets of data. And the mean, I want to add these up. 200 and 200 is 400, 700, 950, 1350. So I'm going to take 1350, and I'm going to divide by 5. And I get 270 for data set number 1. So the mean, we'll call that x bar, is 270 for number 1. Okay? Now the median, as I said, is the one in the middle. All right, so if you put these in order, it would be 200, 200, 250, 300, and 400. You'd have to interchange these two, which means the 250 would be in the middle. Okay? Number 2. If you add these up, 200, 200, 400, 300, 700, 950, and 900 is 1850. 1850 divided by 5, I get 370. So the x bar, or the mean, is 370 for the second set. And the median here, once again, to get these in order, you'd have to interchange these two, and the median is once again 250. Okay? Now, it was really fascinating, and I did this on purpose. Okay? We noticed that the data is precisely the same, except for the 400 gets changed to a 900, right? So the 400 get changed to the 900. Look at the data for the first set. 270 is the mean, 250 is the median. You change that 400 to 900, the mean changes drastically, and the median stays the same. Okay? So what that does is the mean, or the average, goes with what happens to the data. If you insert a very, very high data value, that means your mean is going to jump, okay? Your median stays the same. If you would have inserted an extremely low data value and kept everything else the same, the mean would have jumped down and the median would have stayed the same. Okay? So it means that the mean or the average is not resistant to extreme values. It changes when extreme values change. The median is resistant to extreme values. Okay? You might say, why do I and other instructors use the mean or average when we're doing grades? Well, I use the mean because I want your grade to reflect everything you've done for me, low scores and high scores. Whereas if I use the median, as we just talked about, the median would not reflect low scores or high scores, okay, which can be good and can be bad, all right? Notice the mode is the observation used most often, and in both sets, the mode would be 200, okay? Mean is the average, you add them up, divide by how many. Median is the middle mode, the one that is used most often, okay? All right. A student has test scores. Of those 4 test scores, which measure of center would probably be more advantageous to report to mom and dad? We already talked about why teachers use the mean. But let's check out these scores, 55, 78, 86, and 90. Now, to get the median here, the median is the one in the middle. But wait a second. There's 4 scores. Up here, we had an odd number. It was easy to find the one in the middle. Here, there are 4 scores. It's not easy to find the one in the middle because if you come up 2 and down 2, it's in between 78 and 86. So if you want the score that's in between 78 and 86, which is a little strange here, you would find the mean of the 78 and the 86. When you're dealing with only 2 scores, the mean will give you the middle. So let's do 78 plus 86 and divide by 2. And I get that 82 would be the mean of that data. I said that wrong. Sorry. 82 would be the median of that data. The one in the middle is 82. Okay, now what about the mean or average of all the data? So I must take 55 plus 78 plus 86 plus 90 equals, add them all up, divide by 4, and I get 77.25. So the mean, or X bar, is 77.25. Okay? Which one would be more advantageous to report to mom and dad? Hey, mom and dad, I got an 82 median score in this class. Okay? But most instructors are going to use the mean, and it would actually be a 77.25. All right, number 1. Find the mean, median, and mode of that data. Well, the mode jumps out at you right away, correct? Would be 5, because it's the one used most often. The median, we've got to put them in order. So I would have 4, 2 5s, 6, 7, 8, and 9. Okay, there are all the scores, and thank goodness there's an odd number, 7 of them. I come up 3 and down 3, boom, there's the median. 6 is your median. Now, what about the mean? I've got to add them all up. Can I do that in my head? 10 and 15 is 25, 34, 44, divided by, what did I say, 7? So 44 divided by 7, and I get 6.29. 6.29 is the mean, 6 is the median, okay? And the mode is 5. Everybody with me? Okay. Number 2, do the same thing for this particular set of data. Okay, same thing. Now, does anything jump out at you right away about the mode? We have 2 modes. 7 is used 3 times, 5 is used 3 times, so the mode would be 5 or 7. Okay, now let's put them in order. So I have 3 5s, Okay, I have 3 7s. 3 7s. All right, what else have I got? I've got an 8 and a 9. Is that it? Okay, so I have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, let's find the median. Come up 4, come down 4. It's right in the middle between the two 7s, which is 7. So 7 is the median. All right, how about the mean? I've got to add them up. Can I do that? 15 and 21 is 36. 44. 53. Do it again. 15 and 21 is 36, and 8 is 44, and 9 is 53. 53 divided by, and what did I say there were 8 of those? 53 divided by 8. And I get 6.63 is the mean. Okay? Really easy, right? And now's where it gets interesting. So let's talk about. All right, the town has 5 families, okay? 5 families with weekly incomes of these 5. 6 families with weekly incomes of those 6. All right, got it? Calculate the mean and median of each group. So we have a low group, we have the low group and the high group as far as income is concerned, okay? Let's do, what shall we do here? I guess we're gonna have to put them in order, and I'm just trying to think of an easy way to do this. Well, there's not an easy way to do it without writing them down. So anyway, here, let's take the first one is 200 and 225. We need 5 of these. 300, nope, 250. 300 and 350, okay? So with that information, you can see that 250 is the median. Let's add them up. If I add these up, 200, that's 450, that's 750, that's 1100, that's 1325. So I have 1325 divided by 5 is 265. Okay, so the mean X bar is 265. Okay, I'm going to double check that just to make sure I did that right. 450, 750, 750 is 1100, 1350. Yeah, okay, divided by, whoa, yeah, 1325. Did I do that right? 400, 450, 750, 1100, 1325 divided by 5. Okay. Now, second group, the higher income group. Let's put those in order. And they're close to being in order, except the 900 should be out here on the end. 1, 2, 3, 4, 5, 6. So there's 6 groups. If you put the 900 on the end, 700, 750, 800, and then it's 825, 850, and 900. So it's right between 800 and 825. If you add those up and cut it in half, it should be 812.5. So 812.5 would be the median. Now let's add them all up. I'm not sure I want to add those in my head. So I have 1450 plus 1700 plus 1675 equals, divided by 6 equals 804.17. 804.17. All right, so there I have medians. I've got means, okay, for each group. Now, how about the mean of the town? The mean of the town, you need to add them all up and divide by 11, okay? There's actually another way you could do that, but let's just add them all up and divide by 11, just so I don't confuse anybody. The first one was, when we added these up, 5, 850, 1,100, 1,325, add those up, plus 1,450, plus 1,700, plus 1,675. Grand total divided by, and there are 11 total families, so I get 559 is the X bar for the town. Okay? Now, what about the median of the town? The median of the town, you have these 5 lower ones and you have the 6 upper ones, which mean you have a total of 11, which means you can count up 5 and down 5. And aren't you going to be right there? If you come out up 5 and come down 5, the one that's left over is 700. So the median of the town is going to be the 700. Okay? All right, so there we are. An $80 per week tax is being proposed. Find a percentage tax that would be imposed using the mean or the median of the town. Okay, so if you go back to how we did percentage problems, what is the rate of the tax? Okay, if the total amount of income is either the 559 or the 700, and the tax is 80, right? So you can find your rate of tax by taking 80 divided by 559, and I get 14%, or 80 divided by 700, and I get 11%. Are you with me on what I did? Okay, that's in the middle blank, so it's 80 divided by that one. Now, what statement would be issued by the mayor in support of the tax using a percent and either the mean or median of the town's income? Well, the mayor wants the tax. The mayor needs the tax to help him balance the budget, right? Okay, so the mayor would say, hey, this $80 tax is not a big deal. It's only 11% of the median income, right? It's only 11%. But the tax haters group in the town would say, this is ridiculous. That $80 tax is 14% of the average town income or the mean town income. Can you see how political groups, how focus groups that have a real burning desire to change something can use mean or median in their statements to make it look better for their group? The information is still the same, but your rates are very, very different, okay? And we could have even gotten this better yet had we used the $80 tax in comparison to these two, right? If you would have said the $80 tax, 80 divided by the 265, that rate of tax is a 30% tax. If you take the 80 divided by 804, it is a 10% tax. So you see how the mayor could say, hey, it's not that big of a deal. For the majority of the town's inhabitants, it's only a 10% tax. For the majority, because there's more people in the higher group, right? Whereas the tax haters group could have said, this is atrocious. For the lower income folks, it's a 30% tax. You see? It's the same data, no one is lying, but if you use different forms, mean or median, it can mean so much, okay? And that is the thing I want you to see from this. Intelligent people should understand that. All right, so we are going to be doing some problems dealing with mean, median, and mode, and that will be on your homework for our next time together.